Hello, what I'm going to be covering in this video is recursion, and the example that I will be using is the factorial problem. So to use recursion is to program using recursive methods, that is to use methods that invoke themselves. Recursion is a useful programming technique. In some cases it enables you to develop a natural, straightforward, simple solution to an otherwise difficult problem. All recursive methods have the following characteristics. There's one or more base cases, which is the simplest case, are used to stop recursion, and every recursive call reduces the original problem, bringing it increasingly closer to a base case until it becomes that case. In general, to solve a problem using recursion, you break it into subproblems. If a subproblem resembles the original problem, you can apply the same approach to solve the subproblem recursively. This subproblem is almost the same as the original problem in nature with a smaller size. So what we're going to be looking at is we're going to be looking at computing the factorial using recursion. So the factorial of a number can be recursively defined as follows. If the factorial of 0 equals 1 and the factorial of n equals n times n minus 1 times the factorial, where n is greater than 0. So we're going to let factorial n be the method for computing n factorial. If you call the method with n equal to 0, it'll immediately return the result. The method knows how to solve the simplest case, which is referred to as the base case or the stopping condition. If you call the method with n greater than 0, it reduces the problem into a subproblem for computing the factorial of n minus 1. The subproblem is essentially the same as the original problem, but it is simpler or smaller. Because the subproblem has the same property as the original problem, you can call the method with a different argument, which is referred to as a recursive call. So what we're going to do is I'm just going to go ahead and open up JGrasp and show you the solution to the factorial problem using recursion. So what we have here is we have a class called compute factorial. I'm just specifying integer value of 4. So basically what we're doing in this case is we're calculating the factorial of 4. So let me just go ahead, add a comment. So on line number 8, we're just setting n equal to 4, meaning that we're just going to calculate the factorial of 4. And then line number 10, we're going to display the factorial. And this is where we call our recursive call the factorial function. So basically what we're going to be returning is a long, because factorials can grow quite fast, and you'll quickly run out of space to save them in an int. So what we're going to be returning is a long. Our base case is if n equals to 0, then we will return 1. Else, what we're going to do is we're just going to use our formula n times, and then we're going to call the factorial method again, passing in n minus 1. So this is our recursive call where we continually call our recursive method. So what I'm going to do next is I'll just go ahead and run the program, and we will see that the factorial of 4 is 24. So what I'm going to do next is I'm just going to go back into the presentation, and we're just going to walk through it step by step. So when we're computing the factorial, factorial 4 equals just 4 times the factorial of 3. So that'll be 4 times 3 times the factorial of 2. That'll be 4 times 3 times 2 times the factorial of 1. And then that'll be 4 times 3 times 2 times 1 times the factorial of 0. So basically what that nets down to is the factorial of 0 was 1. We multiply that by 1. So we get 1. Then we take 2 times 1. We multiply that by 3. We get 6. And then we finally take 6 times 4, which gives us 24. So if we walk through the recursive factorial method, our first call will execute factorial 4. So basically what we do on our stack is we go ahead and save a place in memory where we're going to save that return value. And then step 0 executes the factorial of 3. So we return 4. And then we need to multiply it by our next call, which is factorial of 3. So basically what happens on our stack is we reserve space for that return value of factorial of 3. We execute factorial of 3, and then what we need to do next is take 3 times the factorial of 2. So again, we save space on our stack to save the return value for factorial of 2. And then we execute the factorial of 2. And then we make another recursive call. So we execute factorial of 1. So the space required for factorial of 1 gets added to our stack. And then step 3, we execute factorial of 1. So now we've drilled down to a factorial of 0. So if we execute factorial of 1, that will go ahead and return 1. So we've reached the base case. So now what we need to do is we need to go back through the stack and return all of the values to the function, to the methods when we called our factorial in the previous steps. So factorial 0 returns 1. Then we take 1 times 1. Basically what that does is it returns 1 again. Then we take the factorial of 1 times 2. So that returns 2. And then factorial of 2 returns 2. So we take that times 3. That returns a 6. As you can see over on the right, our stack decreases, so we're just winding back up our stack. And then finally, what we do is we return the factorial of 4, which is 24. So recursion is an alternative form of program control. It's essentially repetition without a loop. So recursion bears substantial overhead. As you can see, each time the program calls a method, the system must assign space for all of the method's local variables and parameters. This can consume considerable memory and requires extra time to manage the additional space. Recursion is good for solving the problems that are inherently recursive. And I think that of the 18 years that I programmed at IBM, I think I used recursion about 2 or 3 times. So again, if you can solve the problem using a loop, I would recommend using a loop to solve the problem, but like they mentioned, recursion is good for solving the problems that are inherently recursive. So the next thing I want to do is I want to show you a tool called the Java Virtualizer. And basically what that tool does is it shows the steps at your code step by step as you walk through the Java code. So what I need to do is I need to go ahead and open up that tool. I will place a link to the tool in Canvas so you can access this tool. And what you can do is you can go ahead and copy and paste your Java code into the Java Visualizer tool. And what that'll do is that'll show you your code step by step as you walk through it. So what I'm going to do is I'm going to go ahead and copy and paste my factorial code into the Visualizer tool. So let me just go ahead and escape this, delete it, and then we're going to go ahead and run this. The one bad thing about, or the one kind of thing about the Java Visualizer tool, the one down point about it, is that you can only use one class in the Java Visualizer tool. So if you're going to be calling multiple classes, the Java Visualizer tool cannot handle that. So in this case, what we have is we just have a static method within our computer factorial class, so we can go ahead and run the tool. So what I'm going to do is I'm just going to go ahead and click on Visualize Execution. And what it does is it highlights your code. So I will just click on Forward. Let me just go ahead and decrease the size of this a little bit. Click on Forward again, so we've saved n into 4. Then what we're going to do is we're going to call our factorial method. We're passing in 4. We'll check to see if n is equal. 4 is equal to 0. It is not. So what we're going to do is we're going to drop down to our next line of code in the else statement. What that does then is basically it passes, it sets n equal to 3. So it takes 4 minus 1 and it passes that into our factorial method again. So we'll click on Forward. 3 is not equal to 0. So what it'll do is it'll make another call to our factorial, passing in n minus 1. So n is now 2. It gets passed into our factorial method. 2 is not equal to 0. So we'll drop down. We'll make another recursive call. N is now equal to 0. 1 is not equal to 0, so we'll drop on through to another call. So we'll call it one more time. And then finally n is equal to 0, so n equals 0. So what we're going to do is we're going to return the value of 1. So we'll go ahead and return 1. For the factorial, and that'll be n in this case is 1, so it'll be 1 times 1. So we're going to return a value of 1. So we will return the value of 1 back to our method. N is equal to 2, so it'll be 2 times 1. So we will return a value of 2. So n is now equal to 3. We're looking at the fourth factorial, so it'll be 3 times 2. So we will go ahead and return the value of 6. So we will make the one last call. We need to call our factorial one more time. So where n is 4, so we passed in 6 as our factorial, and then times 4, and what that'll do is it'll return 24, and then it goes back up into our system print line, and then it goes ahead and displays the factorial of 4 as 24. So this is definitely a nice little tool if you want to go walk through and visualize your code as it's walking through statement by statement. If you're going to be inputting values, having the user input a value, then what you would do is you would just click on the S standard in, and then you would specify your input values, one on each line in your standard in, and then that way the program will receive those as input, and you can go ahead and execute those statements and execute that program. So again, I will post a link to this visualizer tool so that you can use it in the future. Hopefully it helps you solve some of the issues with your code if you're having problems trying to debug something. So that's all I had for this video. So again, what we've done here is we've walked through recursion, looking at the factorial, and then we took a brief look at the Java visualizer tool. So I will be talking to you next week.